Welcome, ladies and gentlemen. So what I'd like to do is show you how to find all of the real zeros, or all of the zeros, could be real or imaginary, we don't know, but maybe I do, when given a one irrational zero. So in this case, we're given the zero negative square root of 3. Now remember, whenever you're given a zero and a polynomial, we can always find another factor by using synthetic division. So we know if this is my zero, I can use synthetic division here to take my zero, put it on the outside here of this box, and then take my coefficients of each of my term. Remember, if you're missing a coefficient, then you're going to want to replace it with 0. But in this case, I'm not missing a coefficient. If you're missing a variable term, use 0 in the replace. But in this case, we are good. So first thing I do is bring down the 1. 1 times negative square root of 3 is going to be a negative square root of 3. So now we need to add these. Well, we can't really add negative 5 plus a negative square root of 3. So I'm just going to leave that because one's rational and one's irrational. So I'm going to leave it like this. Now I have to multiply negative 5 minus square root of 3 times negative square root of 3. So to make sure I'm doing my math correctly, I'm going to write that over here. Now we're just going to apply distributive property. Now remember your operations with radical numbers. You can multiply a radical by another radical by multiplying their radicands. However, you cannot multiply a number inside of the radicand if it's not already under a radical. So negative square root of 3 times negative 5 is just going to produce a positive 5 square root of 3. However, negative square root of 3 times negative square root of 3 is going to produce a positive square root of 3 squared, which is just going to be 3. So therefore, I'll write that over here, 5 square root of 3 plus 3. When I add these up, negative 3 plus 3 gives me 0. So I'm left with positive 5 square root of 3. Then I multiply 5 times square root of 3 times negative square root of 3. So I have 5 square root of 3 times negative square root of 3. Now if I multiply these out, I get negative 5 times 3, which is negative 15. And here we go, I have a 0. So now I do have a factor. These are my coefficients, my remainder, my constant, my linear, and my quadratic. But the problem is the coefficients here are obviously going to be these irrational numbers. I don't really want to try to factor or use quadratic formula with irrational coefficients. So what I'm going to do is I'm going to further divide this, because if you remember, any zero that's irrational has its conjugate. So therefore, I can further divide this using my other 0. Now I'm going to take the coefficients of my new factor that I just found, and I'm going to go ahead and factor this down further with my other 0. Because remember, if negative square root of 3 exists, positive square root of 3 exists. So I bring down the 1. 1 times square root of 3 is positive square root of 3. Here, the square roots go to 0, so I'm left with negative 5. Negative 5 times negative square root of 3 is negative 5. Square root of 3, I get 0. So therefore, that's my remainder. That's my constant. And there's my linear. So therefore, I have x minus 5 is my other factor, which is my quotient. And if x minus 5 is my factor, then to find the 0, you just take x minus 5, set it equal to 0, and solve. So I have x equals 5. So therefore, my zeros are going to be 5, and then I have negative square root of 3 and positive square root of 3. All right? Now, there's another way to do this if you're having a little trouble with your operations of radicals. One thing I want you to understand is if we have our zeros, we know we can write them as factors. Just like how I went from factored form, to write it as a 0, I set it equal to 0, and then I solved. So each one of my zeros, I know the same thing is they are set equal to x. Therefore, to write them as factors, I'm going to set them equal to 0. And therefore, I have x plus the square root of 3 times x minus the square root of 3. So I can write them both as two factors. And then if I multiply these, I am going to get another factor that can divide into that polynomial. Because remember, in reality, if this is a factor, that's a factor, that's a factor, all of my factors multiply to give me that polynomial. But if I multiply these two again, you can notice hopefully that the first two terms are the same, last two terms are the same, plus and minus, that's a difference of two squares. So that produces the factor x squared minus 3. So when I multiply them, they produce another factor. And if I can take my zeros, write them as factors, then multiply them to produce another factor, now this factor you can see has real numbers, right? Where over here, yes, they were factors, and they're linear factors, but they're dealing with irrational numbers. I don't really want to be doing anything with irrational numbers. But when I multiply them, I now produce a factor that has real coefficients and a constant, well, I can use long division to divide my factor back into my original polynomial to find my other factors, or factor, right? So synthetic division is kind of way 1. This way is going to be way 2. Just take your zeros, write them as factors, multiply them to get a factor with real coefficients, and then apply long division. X squared goes into x cubed, x times x squared is x cubed. X times negative 3 is going to be a negative 3x. Subtract my rows. I don't have a placeholder here, so that's going to be 0x squared. Doesn't really matter, 0 is not positive or negative. So therefore, when I subtract them, I get 0, negative 5x minus 0. It's just going to become negative 5x squared. This becomes 0. So x squared goes into negative 5x, negative 5 times. Negative 5 times x squared is a negative 5x squared. Negative 5 times negative 3 is going to be a positive 15. Bring down that 15. And again, when you go ahead and subtract, you get 0 and 0, no remainder. So by rewriting my irrational zeros as factors, multiplying them, and then taking that factor, dividing it into my original polynomial, I figured out what my third factor was, right? So then, which we already knew, which we found out this way, once you have your factor, you set your factors equal to 0 and solve, and therefore you have all of your zeros. Thanks.